Hello, students. I welcome you all to today's class. And in today's class, we would be discussing the topic of quadratic equations and nature of those equations. Okay. So everyone, take out your notebooks and note this down quickly. So we would be covering the topic of quadratic equations. So if you see in the previous grades, you would have learned the topic of linear equation, right? So what is the general form of a quadratic equation? We all know it, right? Which is ax square plus bx plus c is equal to 0, where a, b, c are the coefficients and the constants respectively. Now we'll be learning about the nature of the roots of the equation, right? So to find the nature of the roots of the equation, actually there are three different types of roots, right? Depending upon the discriminant value. So what is discriminant, right? So the discriminant is calculated as b square minus 4ac, where b, a, and c are the respective coefficients and constant. Now, depending upon this discriminant value, we can classify the nature of the roots. For example, if the discriminant is greater than 0, right? For example, this value of b square minus 4ac is greater than 0, then I could say that the roots would be real and distant. Okay, so for a quadratic equation, the maximum number of roots would be 2. So those two roots would be distant. That is, there'll be two different values. Okay, now what happens when this value b square minus 4ac is equal to 0? What can I tell about the nature of the roots? The roots would still be real, right? But they would be equal. In the case, for example, the two roots would be 2 and 2, or minus 3 and minus 3. They both will be equal. The last one is going to be where the value of b square minus 4ac is less than 0. Now, in this case, right, the roots would be imaginary. That is, no real roots. Okay, so these are the three different nature of the roots. Just quickly make a note of it and let's take a look at the question. So from this topic, you can expect definitely one question from your exam. If you take a look here, they have given us an equation here and they're asking us to find the nature of the roots. So they have given us the equation where there is this value of k and they are asking us what could the possible value of k be. Okay, but they have given us that the roots are equal. Okay, and what is the value of k? Of course, we know that the roots are equal. So if the roots are equal, I know that the discriminant b square minus 4ac will be equal to 0. Now, first I need to convert this equation, right? Multiply it inside and bring it to the standard form. So that would be kx square minus 2kx plus 6 is equal to 0. Now compare it with the standard equation. We would get the respective values of a, b, and c, right? This is a, b, and c. Now substitute in this formula b square minus 4ac is equal to 0. So I get b is equal to minus 2k, a would be equal to k, and c is equal to c, 6. Okay, now substitute the respective values, students. So b would be equal to minus 2. So minus 2k the whole square minus 4 into k into 6. It should be equal to 0 because they have given me that the roots are equal. Now try simplifying this. That would give me 4k square minus 24k is equal to 0. Let me take the common factors outside, which would give me 4k. K minus 6 is equal to 0. This is it. The question for me was, what should the value of k be so that this equation will have equal roots? So this equation should be satisfied, right? So the values for k is, one possible value is k is equal to 0. The other possible value is k is equal to 6. Both of these are possible, right? But look at my equation here. What happens when the value of k is equal to 0? This whole equation will become 0, right? It'll be just 6 is equal to 0. Then it won't be a quadratic equation at all. So this is not possible value, right? So even though k is equal to 0 is There, this is not possible because the equation won't be a quadratic equation. So only k is equal to 6 is my answer. So when the value of k is equal to 6, this equation would be having real and equal roots. Okay, so they could ask you similar questions in this pattern just by using the formula that we learned earlier. Do you remember all these three formulas? You can apply it in the question to get the respective nature of the roots or to find the unknown. So that's it, students, for today's class. I hope it was a great session. So see you all in the next class. Thank you all. Have a great day.